in different sessions at the IGF, so this session is going to be focused on spectrum management, and I think some of the changes that are happening sort of drive the need to look at approaches to manage spectrum. This session's been organized by APC, who have a number of projects that are focused on the issue of spectrum. One is research on spectrum regulation in Africa, Asia, and Latin America. And the research and reports are available on the APC website. And a very useful paper that's been written by Steve Song on the panel introducing the issue of spectrum. There's a few copies here, and there's another that you can also get on the website. I would certainly encourage those who are new to this area to read it. It's very useful. The other project that APC has is looking at digital migration in West Africa. So it's in the context of the work that APC is doing in this area that I felt it was very useful to have a session. And I think because in interest of time, I'm just going to start by handing over to our first speaker, which is Steve Song, who's the founder of the Village Telco. And he was also the lead researcher for the research done on spectrum in South Africa.
Thanks. So I just want to, my remarks really are to contextualize the discussion we're having. And really this discussion arises from the importance and increasing importance of wireless technologies in terms of reaching everybody and giving access to everybody. Technologies that work in the industrialized world, last mile copper solutions, whether ADSL or coax, are not going to be the solutions, at least not on this continent. Those solutions are going to be wireless. And which brings us to the issue of managing wireless technologies, and indeed the issue of spectrum management. And the key reason for spectrum management is simply managing interference, making sure that signals don't interfere with each other. And the historical approach to doing that was to simply separate signals far enough away from each other that they didn't interfere. And while availability exceeded demand, that was a perfectly reasonable approach. However, in the last say 10 to 15 years, we've gone to the other situation where demand exceeds the available supply, or at least the apparent available supply, and we get into the situation of a struggle around what to do in terms of how to make more spectrum available. So, when we're talking about making more spectrum available, it's important to understand what we're talking about. So what is spectrum? That debate has led to a lot of sort of philosophical investigations of what is the nature of spectrum. And there are people who argue that it is a commons. It's like air, it's like water. There's something that should be shared amongst everybody. It's reusable. A bit like the digital world, and comparisons have been made from open spectrum to open source approaches to sharing things. On the other hand, you have the private property approach, an argument made by Ronald Coast in the 1950s that the most efficient way of managing spectrum was to treat it like private property so that people would pay for it and value it and avoid the tragedy of the commons. And the truth, as usual with complicated things, is somewhere in between. That spectrum is elastic, and we are learning to pack more data into the same amount of bandwidth, and that shows no sign of stopping at the moment. Yet we also know that process is not infinite, that there is what's known as the Shannon bound in terms of the amount of data that you can pack in. So spectrum's elastic, yet not infinite. So how do you manage something like that? Well, it's quite complicated, and it probably needs a variety of approaches, which include private property approaches and include commons approaches where appropriate. And it's important, I think, to have civil society engagement and policy engagement on this issue, because the consequences of bad spectrum management are quite profound. Bad decisions in spectrum management tend to take a generation to fix. You know, failure to make smart decisions in spectrum allocation, because industries build up around spectrum allocation, and incumbents, you know, become entrenched in those allocations. Fixing them takes a very long time. So doing it right is very important. At the same time, failing to do anything is also a high cost, because spectrum is so valuable these days. Taking too long to make spectrum available is also a very expensive error. So you're caught with this, you know, tension of wanting to do the right thing, but not wanting to take too long in doing it. So and things are changing very quickly in terms of the technology for the use of spectrum. We live in an era where technology is getting more and more efficient on the order of every couple of years, so that you know, what we're able to do with the same bandwidth steadily increases. At the same time, the technology to do that is getting cheaper and cheaper, and that means that we may need to think of different paradigms for using spectrum, less in the kind of monolithic, sort of top-down, centrally controlled approach to rolling out spectrum, and a more entrepreneurial, locally driven approach to using spectrum. And all of these things have an impact on affordability of access, on rolling out affordable rural access, on the development of entrepreneurship, and indeed in innovation in the use of these technologies. So I think that's all I want to say at the present. It's really just to kind of try and frame the discussion around spectrum and the importance of spectrum regulation in increasing access.
Thank you, Steve. Next, we're going to hear from Willie Curry, who's a counselor on the Independent Communications Authority of Southern Africa, ICASA. And Willie, I'd just like you to look at what is the context of spectrum regulation in Southern Africa, and how is it changing in the light of digital migration?
Thank you. Well, at the moment, one of the major projects that's underway in South Africa and in Southern Africa is the digital migration of analog TV stations to digital terrestrial television. And this process in South Africa has certainly been running almost for 10 years, I would say, starting off with early investigations, digital migration committee in the early part of the century, and then progressing to a formal digital migration policy around 2006. What I think is significant is the dependency of moving the TV broadcasters from analog to digital to free up the digital dividend of high value spectrum below 1 gigahertz for other uses, and I think particularly in the African context for wireless broadband applications. The problem is that it's not such a simple process, and as I've said, we in South Africa have been going on digital migration for almost 10 years. We're now at a point where it's likely that digital terrestrial TV will be launched formally in April next year, and the government is keen on trying to switch off analog television by December 2013. The ITU has set a deadline of the end of 2015. So one can see that what's involved in this digital migration process is a form of dual illumination. So the UHF band between 470 and 862 megahertz is going to be used both for digital and for maintaining the existing analog channel foreseeably into 2015. So that then has a bearing on when spectrum may be released as this digital dividend. What we've seen is that the World Radio Conference of 2007 at the ITU has set aside the top portion from 790 to 862 megahertz for IMTS or wireless broadband access. There's currently a process around looking at another 100 megahertz below that in terms of WRC 2012 and leading to 2015 to release another batch of spectrum for IMTS or wireless broadband. So in a way, I think there is an opportunity because of this rather prolonged and complex process of switching the analog TV stations to digital, of seeing whether there's an opportunity in Africa, in southern Africa, for the development, the use of television white space technology as a form of wireless broadband provision. And I think certainly in South Africa we're about to be tasked with running an inquiry into this digital dividend spectrum, and one of the things the government is asking us to look at, or will be asking us to look at, is possible uses of television white spaces. So that's roughly what's happening in South Africa is in a way mirrored in the region through the Southern African Development Community discussions, the regular interministerial debates on digital migration, the Association of Southern African Regulators, the CRASA, the Communication Regulators Association, has this issue on its agenda. So I think we're starting to see a real push to make digital migration happen after a long gestation and debates around standards with Brazil and Japan, and a possibility of starting to get our heads around what uses there could be for digital dividend spectrum. Thank you.
Thank you, Willie. I should have mentioned that we're going to ask for experience from a few different regions and then open it up for discussion. And so next, I'd like to ask Carlo Afonso, who's a member of the Brazilian Internet Steering Committee, and he's also an advisor on the APC Open Spectrum Initiative, to talk about the context of spectrum regulation and digital migration in Latin America.
Okay, thank you. Sorry to be late. I was supposed to be in 2 workshops simultaneously, and I took the last 15 minutes or so trying to find the other one, just to say a few words and leave. So I am here now. Sorry. The Latin American perspective, we have a regional forum of regulators. I don't know if you can call it a regional regulator association in the way we would imagine an association that can frame or propose common rules, etc. It's basically a forum called Regulatel. So the individual regulating agencies are relatively independent, depending on the country. We analyzed in particularly 5 countries. In 2 of them, the regulators cannot. In 3 of them, the regulators cannot be considered not even formally independent. No, in one case, it's formally established that it's subordinated to the Ministry of Communications. No? In other cases, they are independent, supposedly, but not necessarily so in practice. And so I don't think this is a picture which is much different from other regions in the world. No? They are subject to political agendas, political pressures, and of course, the economic interests of the large operators. I know that we have short time, so I would straightly jump into the thing of the digital dividend. I have seen that several of the countries have adopted a similar standard, which is derived from the Japanese agency trying to do that. Capacity building for civil society, for any organization that wants it, for people to understand the issues, to understand the technologies involved, the problems involved, etc. And it's it seems very open. They even give the opportunity for the organizations to suggest issues for discussion and suggest ideas and so on. So this is very interesting on the part of the Colombians in a place where basically they are leaving the basic infrastructure to be developed by the market, by the private companies. No? So this is quite an interesting point. And finally, I would stress the importance of following up on the development of the basic fiber infrastructure, because we can create wonderful local area networks using the latest wireless technologies, you know, and even using whatever technology that we can get hold of. And but this has to have transit to the internet. You know? Otherwise, what are we doing? You know, experimenting only. And this transit, well, experience shows that if you don't have a fiber network to carry the bulk of this traffic, you won't do this only with radio in most countries, and in many regional areas, or even in big cities, in very large cities. So what we noticed in the 5 countries in which we had the study developed is that all of these countries are in some way or another taking seriously the issue of developing a national backbone infrastructure based on fiber. No? Brazil is already in with 20,000 kilometers of fiber, and is going to be 33,000 kilometers in 2014, connecting 80 or 85% of the municipalities. Venezuela is doing the same, Colombia is doing the same, Ecuador the same, and Argentina has a major set of rings, backbone rings, interconnected, covering the entire country, being developed right now, and with fiber connections to neighboring countries like Chile, Bolivia, Uruguay, etc. And with the idea that you have to have points of presence of this network in the community, or at least in the municipalities, for the transit to be viable without problems of bottlenecks and so on. And some of them are also tying this to the international connectivity. For instance, the Brazilian backbone is already bidding for 2 undersea fiber cables to Europe and the United States, with plans to do a 3rd one with South Africa. You know? And this, I think, is very important to follow as well, because you have to combine this, the wireless facilities and projects and networks within the communities or small towns or villages or whatever, with the possibility of viable transit to the internet, no? Either the national internet, if you will, or the international transit. Regarding this, one important point that we have to follow is the monitoring of the way in which these plans will treat these points of presence, because you have to have isonomic access to these points. I mean the community, or the local municipality government, or a local entrepreneur who wants to connect its project, its local service provider, a municipal wireless network, to the backbone through that point of presence, and it has to have isonomic access. There is no privileges there. This point of presence must be neutral in relation to who is able to connect to it, in such a cost benefit that makes viable those projects in the community. You know? And this is a very key point, because none of the reports show that there is a policy in this direction, except Brazil, because of the particular fact that I happen to work with, I am a board member of the state company in charge of deploying the fiber in Brazil. But the other ones, we couldn't get a clear word on what will be the way in which local providers of any size, of any type, will get access to these points of presence to run their wireless networks in the areas. More than 7 minutes, I'm sorry.
Thank you very much. I'm now going to turn to Muriaki Murieti, who is an independent consultant in Kenya and who did research on spectrum management in Kenya. And Muriaki, I wonder if you could sort of tell us what are some of the approaches to spectrum management and how they could be implemented in a country like Kenya.
Thank you, Kreya. Thank you for the introduction. Yeah, if I give the Kenyan example, first of all, I think for us to look at the historical context. 10 years ago, we were in a world of monopoly, both in telecommunications and also in broadcasting. 10 years later, a lot of things have changed, and ICT is mainstreamed as part and parcel of our day-to-day life. And so we have seen, for example, penetration of telecommunications licensing from less than 1%. 10 years ago, we had less than 1%, one line for every 100 people, and all of them were fixed, to what we have now, close to 65%. We didn't talk about internet those days. Today we have it, and about 30% of the Kenyans are able and are using internet. And also, we had only one broadcaster some times ago, the government broadcaster. Things have changed. Today we have over 200, and I believe there are so many others waiting in the wings to start broadcasting. This has come with a cost. The growth of telecommunications, internet, broadcasting, and also the private users. And that cost is the need for infrastructure. And that infrastructure is spectrum. And so there's been a challenge on the availability of spectrum. It's inadequate. And one of the things that we are seeing is when the companies are not able to get enough of the spectrum, we have seen cases whereby the bigger companies are swallowing the smaller companies. But they are not interested in their customers. They are not interested in their networks. They are interested in the spectrum. So how can a country like Kenya and many others handle this? So first of all, perhaps we may look at what models that are available to Kenya, to Uganda, to other countries. And so 3 broad areas have been developing or evolving. One, as mentioned earlier by Steve, is the administrative, whereby the regulator, the government, or the government agency will say, yes, we are allocating this frequency for this, and we are allocating you to do whatever you want to do on that frequency. And so the key thing is the issue, is technical parameters, is the issue of interference. And this has been there for a long time in our country. Historical has been there. And this is one of the reasons why we are seeing of some of our companies buying up smaller companies that have got the spectrum. But one of the other challenges arising from it is the case of penalizing the rural consumer. Out there, you buy frequency at the same price, you use it as for the urban as well as the rural areas. It means, therefore, with the same cost structure, when you go to the rural areas, then and population is disbursed, they are more disbursed, it means that user would have to be penalized by that process. Another way of looking at it, which the regulator is looking at, is a market. Yes, if companies are prepared to buy off smaller companies with the spectrum, so can we be able to realize, discover an economic value, an economic light, and so in the process, therefore, cede the rights of that spectrum. Now, our regulator is considering this, and it's part of the strategic plan to consider discovering the price, looking at the economic value of that spectrum. One challenge that has to be addressed is that we have one big company known as Safaricom, and I'm almost sure that most of you are using the spectrum. I mean, you are using that company. It's got about 75% market leadership. And so, when you put out a block of spectrum for sale, who is going to buy it? So, and this may end up reinforcing the same dominance. And so that's one challenge. 2, if we do that, it means again, those guys out there in the rural areas, those guys in the urban areas who are disadvantaged, it means now they are, of course, switched out of that equation. The other area is, of course, to look at it as a common resource, all can play, so long as we satisfy some technical criteria. So with this, CCK, our regulator, is looking at how can we put out more spectrum to serve our ever-growing ICT system. So they are looking at three processes. One, the government historically had a lot of spectrum for historical reasons. They had a lot of spectrum. So the regulator in its strategic plan current is looking at ways to work with the government, perhaps even in some incentives to migrate some of the government agencies to be able to release some of the spectrum. The other area, of course, mentioned earlier by Willie, is the digital dividend after the migration, and the country is working very hard that by next year we should all be digital. There's a lot of work going on that area, and so the intention is how to release part of that spectrum to serve the ever-growing need. The other area also mentioned by our regulator under very serious consideration is also selling some of the spectrum, but as I said, we still have to address this issue of the impact it will have downstream, the impact it will have in consolidating our already very monopolistic market. And finally, the government, the regulator is always looking at its table of frequency allocations and also regular frequency spectrum utilization audits. The intention is to see, are we utilizing all this resource properly? So all these models are at a discussion at various stages by the regulator. Now, one thing that perhaps I would like to note out of, this is based on a study that we carried out last year, is that spectrum appears a very technical issue. It is not yet gone to the public domain, despite the effect it has in the use. So it is not yet, it is literally a technical issue between the operator and the regulator, but is not yet gone to the public domain. We think it's a high time this issue goes out so that people can see the implication of decisions taken, allowed the assignments, the allocations, allowed consolidation, and allowed the three models that are going to be used. Thank you, Kriya.
Thank you very much. I don't know if there's any quick points of clarification people wanted on the previous speakers before we go on to the next. As I just at this point, just for any points of clarification. Okay, then I'll proceed on to our next speaker. So we've heard a bit about what's happening in different countries, and now we're going to broaden the discussion out a bit again. So next will be Sasha Menra, Director of the New American Foundation's Open Technology Initiative. And Sasha, I was wondering if you could say how new technologies can contribute to a shared use approach to spectrum management.
Sure, happy to tackle that. I work in a DC think tank working on cutting edge policy, but I'm also a telecom historian. So I thought I'd start with a simple quote. It is probable that many of the greatest inventions and improvements of the future will come from amateurs who, by experimentation, chance upon undreamed of things. And, you know, as one does when you're in my field reading through telecom history, you think, like, this is really interesting. It's so relevant to the world that we live in today. This was written by A. Hyatt Verrill in a book called The Home Radio, How to Make and Use It, from 1922. So you can imagine in that era, and the 1920s were probably one of the most vibrant, innovative decades for electromagnetic spectrum use in human history. It pioneered the broadcast model, which has been with us now for 80 plus years. It led to most of the inventions and, quite honestly, most of the spectrum policies that are still with us today. And so what I really want to focus on is this notion that we have analog regulations for a digital world right here, right now. We have radio, we still have guard bands and guard zones, we have exclusive use, we use a broadcast business model. that doesn't map onto the possibilities of today's technology. And what you have from 1922 to 1934 is the systematic enclosure of this technology, the removal from these amateurs and innovators and entrepreneurs of control over the broadcast medium, and instead housing that in an ever-decreasing number of corporate entities. And on the one hand, this led to the spread of this communications medium, but on the other hand, it really retarded the continuing evolution and innovation in this space. Now, in 1927, 1934, with the creation of the FCC, they said, we're going to put this to the most valuable use, which is the same, exact same rhetoric that is used today. And what I worry about is that we're in danger of repeating this history. The key innovations, better, cheaper, more efficient models are going to be ignored, and in fact are today actively being suppressed. And I'll give you 3 examples. One is one that probably almost no one here has heard of. It's called the interference temperature proceeding. And what it said was that it was possible, as we are demonstrating right now, for someone to broadcast quietly while the main speaker, the main broadcaster, was happening. So in this room, we're demonstrating here. I'm speaking, they're talking. We both can operate in the same space without causing harmful interference to one another. That exact same phenomenon is entirely possible in broadcast media. A number of us fought for this proceeding. Eventually, the FCC decided not to rule on it, and it is now dead. But could be resurrected and certainly could be implicated or implemented in other countries around the globe. Number 2 is what's pending today, television white space devices. And I actually hope that Paul will spend a little bit of time talking about this, because I think it is right now a technology that is ripe for implementation, that could roll out affordable both broadband connectivity and local area networking to areas of the globe that otherwise couldn't afford the dominant business model or have needs or uses that they want to put these technologies to that aren't met by the dominant business models. And number 3 is what I'll call a proposed solution, which is the unlicensed GSM bands, something that I talked about a little bit yesterday. But this notion that if you had unlicensed bands, you would provide excess capacity for those that need it in areas of congestion, while still making them available to communities, entrepreneurs, individuals that want to use these spaces in places that are under or unserved. It would cost us almost nothing. We've seen this demonstrated with the AT&Ts and Oranges and what have you of the world, where they're offloading smartphone capacity to Wi-Fi hotspots. We were talking, Steve and I, earlier today. It's somewhere between 35 and 40% of all AT&T iPhone traffic gets offloaded to an unlicensed band. So I say, hey, that's great. Let's do that writ large all over the place. But let's not give you the exclusive license, which is what I constantly hear everyone talking about today. Give us more exclusive licensure of additional bands, and somehow everything will be great. Well, tell that to all of the people that can't afford the dominant business model. Tell that to all the people that have been left unserved, the poor, the rural of the world that haven't yet received connectivity. So all of this falls under, I think, a simple rubric, which is that what's before us today is the shared use of electromagnetic spectrum. And I think it's the single most important issue facing spectrum regulators today. The single most important issue. And the real question is, are we going to learn from history, or are we simply going to repeat the mistakes that we've made in generations past? Thank you.
Thank you very much, Sasha. Next, we're going to hear from Daniel Wilson, who's a senior policy advisor at the BBC. And Daniel, I was wondering if you could comment on the sort of state of debate around use of spectrum in the UK.
Thank you, Claire. First of all, I wanted to just say what an excellent paper I think Steve's paper is, and I think it speaks exactly to what Mr. Morathi was saying before about the importance of bringing this debate to the public domain by using such accessible language. I think as someone who was brought to the panel rather late in the day, it was a particularly useful reminder to me of some of the history of this. The UK is often taken as an example of a market-based approach through the spectrum auctions that our regulator Ofcom has led, and actually has been seen as an example across the European Union for how spectrum can be managed. But I think it's important to notice that the spectrum auctions are only around part of the available spectrum, and they're only part of the debate. And the debate in the UK and in the European Union looks not just at the economic value and maximising the economic value, but also the crucial public value of spectrum. Because after all, it's a very scarce public resource, and it's important in all these decisions to factor in the social, cultural benefits that come from spectrum use. So the BBC can certainly appreciate the value of social as well as economic value of using spectrum for mobile operators, broadband operators, who, after all, are most likely to be the highest bidders for available spectrum that competes in the same bands as broadcasting. And to be honest, the internet is a core platform for the BBC. We're investing £600 million until 2017 in broadband infrastructure, as well as £100 million a year in broadband content. So it's a crucial platform for us, and definitely one which will be ever more important. But it's also important to notice the disadvantages which come with allocations or with auctions won for mobile use, for internet use. So first of all, it's a one-to-one technology using IP. Using television is a one-to-many technology. It's a merit good. So the more people who use television, it comes at no extra cost, and you get the social benefits of something which is universal, free at the point of use, and something which in the UK is in 19 million of the 25 million UK households. So it's something which can really deliver social value in bringing the nation together and getting out social, political, culturally valuable content, which government has decided is something, and society has decided is something that's worth funding to the whole population at no additional cost in transmission costs, irrespective of how many users there are. And I think that concept of universality is very important, because it's not something which is very easy to deliver in many areas. We've heard about the problems of rural broadband before. It's still very much an issue in the UK, striving towards universal broadband access and high quality broadband access. But the cost of reaching the last 10%, the last 1% is extremely high, and government are looking to invest in doing so. They're needing to subsidize it, but it's something which you can see that different technologies have their different advantages. Just going back to the UK history of how we got to the market-based approach, we had a digital switchover. It's due to finish next year, shortly after the Olympic Games in London. Alongside the digital switchover, there was a massive government marketing campaign, but also social help for those who might be left behind. £600 million put aside to help the elderly, the disabled, to switch to digital. And again, when looking at spectrum allocations, broadcasters were very keen to promote digital television. It's far more efficient. We can use more channels aside from all the potential use for broadband. But you do need to think about the people who might be left behind along the side. There's also the interference issue, which is quite large in the UK debate at the moment. So the 4G spectrum, which is going to be auctioned off in the UK next year, hopefully, but it's been delayed for many years through litigation from the telcos largely. But the regulator Ofcom think that that might interfere with 3% of digital terrestrial television sets, which, when you think 3% of those 19 million homes, is a lot of people, and a lot of people, again, who might be the least able to adjust to this change. So again, I think the key there is factoring in that social context. So the UK is switching next year. The European Commission hopes that all countries will switch by 2012, I believe, although I'm not sure that's necessarily going to happen in every country across the European Union. And we're now looking at whether there are potentially a second digital dividend in Europe. And I suppose to come back to my core argument in that, but also in looking at whether in developing countries you might potentially leapfrog digital television and go direct from analog to IPTV, you've got to think about the benefits of the universal access, the free access to digital terrestrial television that isn't pay access to content which society has judged is valuable for both social, democratic purposes. So absolutely think that spectrum auctions can be a key part of the solution, but you have to bear in mind the trade-offs involved and factor that into the decision-making process from the very start.
Thank you very, very much, Daniel. And our final speaker is Paul Mitchell, who's a Senior Director at Technology Policy at Microsoft. And I was wondering, Paul, if you could comment on the opportunities for multi-stakeholder collaboration around spectrum use and management.
Sure. In fact, this panel right here is a good example of the multi-stakeholder need to address spectrum holistically. One of the challenges that have been presented here are the need for sort of universal access to content that's preserved by the broadcasting model. We've heard about the difficulty of actually building out last mile broadband. We've heard about interference problems. When you come right down to it, though, we have a situation where in most of the world, in reality, most of the spectrum is actually not used most of the time. What we have is a set of allocations based on perceived public benefits, some of which are real and some of which are actually intangible and unknown, and allocations based on business models. And as was earlier stated, there's a real need to sort of bring the models into the digital age as opposed to leave them in the analog world. So when you think about multi-stakeholder, it is really something to address this is something that needs to involve industry, government, the civil society in general, and needs to factor in all of the different needs, but use modern technology to come up with solutions for this century and the next century, not the last century. As one example, we have been working with a number of partners, actually including the BBC, in a trial of white spaces technology in the city of Cambridge in the UK. And the purpose of the demonstration, which includes the regulator Ofcom, Nokia, BBC, Arqiva, Newell, and I'm sure I'll miss some, Samsung, Microsoft, who doesn't actually make anything in this space. We're just trying to be a catalyst to make more broadband happen. And the purpose of the trial is really to demonstrate that we can, as a collected group of participants, successfully use white space technology without interfering with anything to deliver on a range of scenarios. And those scenarios include regular sort of in-city broadband, rural broadband, smart city applications, location-aware services, and then entertainment and media services are all use cases that are being demonstrated and trialed in the city of Cambridge. Something else that we've been doing is we have a set of spectrum observatories. Spectrum observatories are essentially test and measurement units that every second sample all of the spectrum from 0 to 6 gigahertz in this case, and they make a record of what's being used. And we have 2 of these in the Puget Sound area near Microsoft's headquarters. We have 1 in Washington, D.C. And these have been up and running for a while. And in the city of Seattle, we have several airports, we have several military installations, we have a very wired, mobile-aware society. We have every conceivable use of spectrum that you could imagine. And again, when we look at the plots of the actual usage of spectrum, we find that most of the spectrum in that area, most of the time, is actually unused. Some of the models that we have today for allocating spectrum are roughly the equivalent of reserving spectrum for marine traffic in the Sahara Desert, which doesn't actually make sense. So in terms of the trial aspect, what we've tried to do is pull together all of the representatives of all of the associated stakeholders, not to presuppose a particular business model, not to presuppose a particular application, but to demonstrate that the technology is capable of doing amazing things. And if all the stakeholders can get together and actually recognize how these scenarios can play in society, that conversations change from protection of the status quo to how can we do more, how can we do it better, how can we help build out our broadband universe across the planet. In this continent, using spectrum is pretty much the only way to deliver broadband to most of the continent. The reality is that the costs of running fiber connections to rural Africa just so staggering that it will, in my lifetime, certainly never happen. On the other hand, using broadband, using wireless technologies efficiently, especially those that can be brought in at consumer cost curve economics, has the potential to really open up a world of opportunity, economic development, better healthcare, better access to education throughout the developing world. And that's really what we're focused on, trying to bring the digital benefits of the digital age to consumers across the planet. So stop there.
Thank you very much. So now I'd like to open it up for comments or questions. And Henrik, is there any remote participation? No questions. Okay. All right, if you could introduce yourself and where you're from.
Okay, thank you. My name is Daniel Obam. I'm from Kenya. I'll just start off with the example of a gentleman who said that we are reserving spectrum which is not used. As I sit here, I have a computer which has an operating system. I have a phone here. I've sat here for 1 hour. The phone has not rung. So does this imply I should give it to my neighbor to use it just because I'm not using it? In another meeting where I was in, my neighbor had an iPad, a laptop, and a phone. So really, in real life, it's not possible to use things 100% of the time. But that's beside the point. I'm just confused about what's the definition of white space? Is it an internationally accepted definition, or is it something that is being tried out in one country and therefore it's being, exported? And is white space between guard bands or frequency channels, or is it spectrum that is going to be made available when migration occurs and we clear a swath of spectrum? Perhaps we need to define what white space is, because I've heard different people talking about white space and talking about totally different things that actually are confusing me. But there I heard that the origin of the word white space came from the printed page, which is the space around a paper which has not been printed on. Because it's not possible to print words on every single piece of paper. So even in printing, there's a reason why they leave white spaces so that you can be able to read the words that are printed on paper. Those are my initial comments. Thank you.
Right. Can I just check if get a couple of questions and then pass them back to the panel? Are there other? Sorry. Yeah.
Thanks very much. My name's Elizabeth Migwala. I work for a company called Qualcomm. I just have one question, and that goes to the last speaker who talked about bringing these services at consumer price points. I'm very interested in that because I'd like to get a feel for what those consumer price points might be and how the technologies we are talking about today would improve on maybe some of the technologies that are today widely used by the populace in Africa. Thank you.
Are there, maybe one more question, then we'll go back to the panel. So you had.
Hello, my name is Bala. I'm a member of APC. My question goes to Sasha, I think. You mentioned something about, I didn't get the full name, but something about low-level temperature, something that is somewhere dead now. I think maybe you should elaborate a bit more about this. If it's dead in the US, it might be something that people in the developing world can look at. I think that's, yeah.
Okay, I'm going to go to the panel, then we'll open for another round of comments and questions. So I don't know who wants to tackle what first.
Okay, so I'll tackle the white space thing. Just to be clear, when I talk about white space and when anyone from Microsoft talks about white space, we mean the unused but allocated spectrum in a particular range of bands. So if we're talking about the TV bands, the spectrum in a given place, like right here, that within that set of bands is currently not being used. And so the white space in different cities in the television bands will differ. So in the United States, as a simple example, in Seattle, channel 2, 3, 4, 5, 6, and 7, 2, 3, 4, 5, 6, and 7 don't exist, but channel 12 does. So I could use 2, 3, 4, 5, 6, and 7 in Bellingham, but I can't use them in Seattle, but in Seattle I could use channel 12 as an example. So the demonstration that we actually had a demonstration here in the stand until this afternoon, when then the radios had to go back to the U.S. The channels we used here, which we were demonstrating in the TV bands, were channels that are currently not being used by any broadcaster right here in this geography. So does that answer your question? And the other, you asked a question about price points. Just quickly. The white space technology that our partners are working on is designed to follow the same cost curves as typical Wi-Fi devices. So today, a standard consumer access point is about $30. Wi-Fi chipsets are essentially in every computer, every mobile phone, virtually everything. They're very, very inexpensive. They started about $1,000 and they went down. And the white space radios should do approximately the same thing.
Steve and then Sasha.
Yeah, I just want to speak a little bit more generally about white spaces, maybe expand the definition a little bit in that white space technology, so I think, represents the future of spectrum use in the sense that it is serendipitous reuse of spectrum using spectrum sensing techniques. So what we've gone from is, spectrum regulation is based on the early days of broadcast, where the technology was relatively crude and you had to have a television transmitter that was shouting in order to reach the comparatively deaf television sets that existed back then. In order to make that feasible in terms of having different channels, you had to have guard bands separating those channels in order for for there not to be interference. And that the white space actually refers to, in the old television sets, when you get that noise on the television set, that sort of white snow, that's that guard band in between the television channels that was empty because of the sort of relatively deaf and shouting kind of technology that we started out with. Where we are now, we have much more delicate equipment that can listen and sense if anybody else is talking in the room, and if somebody is talking in that room, if somebody's broadcasting, move to another room and do it dynamically and automatically. So rather than having to permanently allocate a space to a particular user, you can serendipitously and through technology and not through regulation or through policy, reallocate and reuse empty bits of spectrum. Right now, the television bands are the real opportunity for serendipitous reuse, but really this kind of technology could be applied across the entire spectrum band.
Sasha, did you want to?
Sure. So I wanted to touch on a couple of the other things, but I did want to touch also on spectrum is one of these strange, it's probably one of the only natural resources that no matter how much you use right now, renews itself to 100% the next millisecond. And this is important because actually when you aren't using your phone, if your neighbor has the same phone company, he may be using that same spectrum. And in the same way that you can coordinate that use, you can actually coordinate not just with another cell phone with the same carrier, but across a number of different devices that may or may not be locked into that one carrier. And the notion is just, if you listen before you talk, if you analyze before you broadcast, which is what smart radio or cognitive radio technologies do, you actually can make far more efficient use, because millisecond to millisecond, you can infill those frequencies that aren't being used at that one moment in time. And you can do so without causing any adverse effect the next millisecond. In terms of interference temperature, so there's electromagnetic radiation all around us, right? Light is electromagnetic radiation. And in every single frequency, you have signal and you have what's called noise. It's the background radiation that's always with us. The interference temperature is simply the level at which that noise would interfere with a signal. And so you can imagine if you broadcast below what's called this noise floor, you won't cause interference to the main signal. And so what I was talking about earlier, how people can whisper in this room and I can talk, and their whispering doesn't make it impossible for me to talk or for you to hear what I have to say. That same phenomenon exists in electromagnetic spectrum. And so what you can do is you can imagine in a television band with a 100,000 watt station broadcasting out, you could have a 10 milliwatt device connecting a couple of things together with no possibility, no realistic possibility of causing harmful interference. And this enables all sorts of other uses within the same frequency that a primary broadcaster may exist in. And I finally wanted to touch just briefly on the average return per user and business models, et cetera. A lot of what I do, wearing into my other hats in doing community wireless networking, we have found that the connectivity is so cheap, it does not make sense to measure. That we're able to repurpose available connectivity, that we're able to provide models for sharing connectivity, that drop the cost of broadband access to a level so cheap, we're talking about 1 to 3 cents per user per month, that setting up a system to actually bill people, that transaction cost is far greater than the cost of the connectivity itself. And I think this is what's possible when you start thinking about other models for delivering connectivity. And we just have to get there as a society in terms of thinking outside of the box of a specific kind, a specific way of delivering broadband access, et cetera.
Did any of the other panelists want to comment on the questions that have come in yet? Carlos.
Just said, Vint Cerf, when he was at MCI, he said to us that if they could go back in time, they would never charge for long distance costs on the basis of the measuring the minutes, because the cost of doing that would, with the automatic switching, etc., would not anymore, be worth it. So even at that time,
Okay, so I'd like to open the floor to the next round of comments and questions. Okay, so we have one remote and 2 people here. So maybe we'll start with the remote and then the 2 gentlemen.
Sure. This is Lilian Chamorro from Colombia. She wants to know what could be the role of the regulator if a policy of open spectrum is accepted.
And gentlemen, do you want to come to a microphone?
Yeah. My name is Tumisani Moyo from Open Society Initiative for Southern Africa. My question is to do with the cost of digital migration. What what would it mean for poor countries that are battling? 2015 is the deadline for migration. It's also the deadline for MDGs. So what are the chances that most African countries are likely to be left out? And what will be the implications? Thank you.
Yeah, I'm Yoshihiro Obata from eAccess, which is a 3G mobile operator and also ADSL wholesale provider in Japan. And also, I'm a director for Japan ISP Association and one of the organizers of IGF Japan. I would like to make a couple of comments based on our experience, starting from ADSL operator to 3G. Firstly, we had many discussion among operators and also had chances to exchange information with several carriers in Europe. That basically what you see is that, especially because of the youth generation, which catch up in this digital world very fast, that after introduction of broadband and internet to the community, it seems that the demand for any, the traffic demand for any person is not too different from any country to another country. That was from our experience when we started ahead of British Telecom, ADSL, that after 2 years they caught up with our demand, and then we saw a similar traffic pattern, similar traffic pattern means per application, and similar traffic pattern per hour, and similar volume of traffic per person. So, I was in one of the other workshops where they were discussing IX points in Africa, and what I noticed was that still the current African internet traffic is pretty much research and business, because if you see other developed countries, the peak hour of internet traffic is around 10 p.m., 11 p.m., or in some cases midnight. So I think there will be a very quick transition in this region, that you start from this business and research oriented traffic to a consumer traffic, where the volume is much different and the peak hour is much different. And if you reach that level, it will be something around 50 to 100 kilobps per second at the peak hour per user. I'm talking about per subscriber. And secondly, from our experience, where we are handling about the similar size of NTT Docomo traffic under only something around 10 megahertz of spectrum, where Docomo has more than 10 times of their spectrum. There's a big difference between circuit switching and packet switching on the wireless network. So that it seems that if you move to pure packet switching on wireless networks such as HSP or LTE, you can improve the real spectrum efficiency more than 10 times, which means that you have to consider how you will handle voice under the current spectrum usage, because there is much difference in the usage. And from our experience, especially, you know that the most challenging is the dense population in Tokyo. That under such a configuration where you have many buildings which have like 20 stories or 30 stories building, and when you come to the technology limit of about 100 meter radius for a base station, which is very, very dense, that you can only handle something around 1 million or 2 million users per 5 megahertz pair. So of course the population density varies from one country to another country, but once you have these high story buildings, and then you come to the technology limit of base station coverage, then you'll see similar size because of the technology and also the demand, which is about 50 to 100 kilobps per second per user. So and secondly, at that limit, although these 700 to 900 megahertz traditionally looks like a premium spectrum, at that very short radius, then even something like 2 gigahertz will also be to work in a similar manner than the lower spectrum. But which means that there is a need for different policies and different maybe business models in the rural areas and in the city. And from our experience, especially in Japan, where the number of basically mobile users and even the number of mobile internet users are nearly saturated, the customer demand is of course flat rate because they don't want to pay per volume. And at this stage what happens is that whatever you improve, then there will be no more income coming in for an operator. So at this stage, the only thing which survives is a switch of the business model, and that's why a lot of the Japanese operators are moving towards Wi-Fi offload. But then there's a challenging issue that whether you can offload private traffic to a public, access line, or even a private access line, which does not belong to a private operator. So there are many complicated legal and also business issues at this level, which I expect that even in this region, looking at the development of large cities, that in several years it will come to this stage very quickly. So if you don't expect that this transition, very quick transition in a small number of years to happen, then at some point what you'll see is saturation of the how do you say, supply, or maybe even customer complaints or various troubles coming in very quickly, what you see on some of the cities where the traffic on the road is so bad.
Thank you very much. I think the time is starting to run out, so if there's anybody has any very quick question, very quick comment, and then I'm going to pass back to the panel to sort of go and make their final comments.
Yeah, my comment is related to the comment that we probably don't need the fiber for people to access have access to content using these white spaces. But generally in rural areas we don't have content. Content resides elsewhere. So I think they still need to build the backhauls that will take content, especially to a school, if you want to get content from elsewhere. So you still need the fiber or high capacity backhauls. The second comment is that I'm involved in migration in Kenya, and a survey was done. Out of the 5 million TV sets, 43% were black and white. Therefore, those nice devices that we're being told, they sound like cake, but actually what we want is just bread. So a time will come when we can have the cake, but for us in Africa, we are grappling with the basic thing of just migrating first using the current screens, the current broadcasting technology. Then after that, I think we can have now the second successive levels of migration. Thank you.
Okay, I'm going to ask each of the panelists to make any final comments, and I think maybe we'll go around the circle, starting with Willie. Do you have?
Well, just on the costs of digital migration, yes, there's the cost of the migration itself, but there's also the opportunity cost of not migrating in the next 5 years, which is not then having access to the digital dividend in terms of mobile communications. But on the other hand, strategic introduction of white space technology might counteract that.
I want to address the question from Colombia, what is the role of the regulator? I think the role of the regulator is, on the one hand, to bring about public engagement and consultation from industry, from government and civil society on these issues to make the decisions that are in the best interests of the country. And I think the current discourse that tends to go on at the regulator happens mostly between industry and government, and there needs to be a stronger component of civil society involved in that. But on the other hand, the role of the regulator is also basically to fail safely, because what we've seen in the history of spectrum management and technology, these facts about the 80% or more of the spectrum being available. The reason that is true is because either we misunderstood what technology was going to evolve, or we misunderstood the person that we gave the, or company that we gave the spectrum to. So if you look at those complex spectrum allocation charts, they're filled with technologies that don't exist anymore. And, I'm always chastened in reminding myself of, events like this that, not 10 years ago, the word mobile phone wouldn't have featured in this discussion. 5 years ago, if we were talking about the future of technology, it would have been WiMAX. 2 years ago, nobody would have brought up the issue of tablets at this discussion. So I think we have to be very humble in our sense of what we know about the future, and therefore need to design policies that are very adaptive and that we can recover from the mistakes that we will inevitably make. Thanks.
Miriki, any comments?
Very quick, just echoing the question from Korubia. It is not feasible that all the spectrum can be under the commons. What we are having, and we are perhaps likely to have for a long, long time, because of the various users, will be a combination of all the three models. And so a regulator will still always have a lull. Perhaps what we need to start thinking about is moving away from calling them a regulator to a facilitator in future. Thank you.
Since we're going down the line, I guess, I just want to +1 that comment. I think, what we're really pushing for is a rich ecosystem of different spectrum regulatory frameworks. So, we have, what I work on is actually 7 different options. And actually, if you Google 7 key options for spectrum, you'll pop up some of my work as your first hit. And the notion is you want all of these different elements. You want licensed, you want unlicensed, you want light licensed, you want interference temperature, you want all of this in the space. That's what gives you the most diversity, which enables you to meet the most different needs, which are also equally diverse. And I think, when I think about the different tech and business models, it's important to keep in mind how spectrum regulation has come about. And for better and for worse, most of it starts in the United States, and it usually starts in a major conversation at the Federal Communications Commission between a very few civil society folks and a huge number of incredibly wealthy, incredibly active, massive US-based telecommunications groups who are trying to figure out, how do I maximize my profit? And then the rest of the world kind of harmonizes around the decisions that the FCC makes. For most of the world, the business model that those decisions are based on doesn't fit your reality. And so you have to ask, would the regulations that were made, the decisions that were made based on that business model being pushed at the FCC, map onto my on-the-ground reality? And if your answer is, my community isn't like suburban Washington, D.C., you may want to think a bit more about what regulations, what key decisions better map onto my country.
So I guess it'd be the +2 on that. I would just add that a key role for the regulators right now is to facilitate innovation and discovery and discussion, and not get in the way of trying out these new technologies, but actually to facilitate ways to expand the understanding and expand what can be done. And as Sasha said, to think about what your reality is. If your reality is, need for education facilities in a rural region that doesn't have broadband, then what's the best way to get broadband there the most efficiently? If your reality is we want to have a lot more reality television, more television, but really think about the societal needs, and from the perspective of where we are today in time and where we're going, not where we've been.
Thank you. I suppose +3 is a crowd, so I won't, but I do very much agree. And I think one of the interesting things that happened in the UK digital switchover was the emergence of groups which had initially been overlooked by the regulators. So particularly the use of wireless microphones, not just by broadcasters, and cynically you might say the reason that enough notice was taken of this community because the broadcasters made their views very clear and added some muscle to the community groups who raised this issue. But lots and lots of theatres, small community groups who use wireless technologies and might have been overlooked in the process. So in the sort of cost-benefit analysis that you do of migration to digital, you have to factor that in, as well as the broader economic benefits, but also social costs of those technology moves, whether it's buying new equipment, but also the loss of what there previously was. But all sorts of potential for better use of spectrum. And I think one thing that certainly I hope is more widespread than just European broadcasters is a duty on them to use their spectrum efficiently. So we're constantly trying to come up with new standards, try out white space technology as we are in the trial in Cambridge, but also look at standards like DVB-T2, which is a standard which has allowed us to launch many more television channels, but potentially also you know, spectrum which could have been used for other uses too.
I think I can complement a bit what Steve and the speaker from Kenya and Sasha as well said regarding Lilian Chamorro's question. I think that another thing is that we have to make sure that we do not lose what we have already conquered, which is the very small parts of the spectrum which we can use as non-licensed or unlicensed or to a certain extent open spectrum. Just an example, you know, in the Wi-Fi world in some of our countries, you have a limit of transmission power of like 400 milliwatts. Also, you cannot transmit beyond your premises, your legal premises. So you cannot transmit beyond your house, you cannot transmit beyond whatever, your school. And then if a community association wants to use this technology, it doesn't pay any license, and to cover the entire community using just 400 milliwatt radius, they can do that, but they will have to pay a license. So we lose the open spectrum already characteristic that we have. So we have to fight for a community that can use what is already open or unlicensed, not to have to pay licenses to operate a small network, Wi-Fi network within their communities. There are some cases in Brazil, for instance, which people are getting arrested because of that. They are not charging anything. They are operating 400 milliwatt radius, but the signal is going beyond the premises. And someone else is using, you know, with their knowledge. They cannot do it. You know? So this I think is a terrain that we have to preserve, besides trying to conquer more terrain for the open spectrum idea. That's, I think, my point.
So, thank you for everybody. I guess it's up to me now to just do a few kind of summary comments. What I sort of picked up in this, I think, very interesting discussion was that it's a time of change, technical change, and a time of opportunity, and that the regulation of spectrum is an issue that the management spectrum is an issue that regulators are currently really grappling with, and I think not one where there's finding any easy answers. Also that more people need to be involved in the discussions about spectrum so that their interests are being heard. But that it's a time of opportunity where if with changes in the way that we manage spectrum, you know, offers opportunities to get those connected who aren't connected and to use the spectrum more effectively. And that a key dimension to this is flexibility and in the way that spectrum is managed. I don't know if hopefully that sort of sums up some of the key points. I just want to thank very much all the panelists for their time, and for Valeria and Henrik who did the remote facilitation, and for Pablo from APC who pulled together this session and the speakers. I hope everybody's found it useful. Thank you.